Welcome to Wickerson Studios. I am continuing with the machine learning section of the ghPython one-liners. However, I'm actually bringing it into ghPython remote out of a textbook that's just specifically for learning Python. So there's a few tricks in here, but once you get it up and running, I just want to show a few of the very novice or introductory things I'm doing. Here's a piece of geometry, obviously. It changes. It's a simple loft through circles. That radius is defined by the predict values coming out of a linear regression function. And I use these on Patreon. I actually am starting to get more Patrons, which I'm very excited about because I'm sharing the user objects and the scripts. This is a much larger script, and we're only into chapter 4. But it's the intermediate advanced, and I'm just going to zoom out here, and you can see that this is quite a bit of data and information. I've gone over videos talking about branch management. I've gone over the videos on ghPython remote node setup and how to import these modules and libraries into this ghPython remote. I have a base jazzy script that I like to use all the time, and now we're importing scikit-learn, which means we are into machine learning to drive geometries. I'm starting to generate notes. I'm starting to make these files a lot more informational out of that book as I translate them. And I have files on linear regression that you can see here. It pulls out the NumPy arrays, which I don't really know much to do with, but then I start to play with this data, not only playing with it through linear regression and predicting on both sides of this function numbers. You can see that 68, you can see the negative, took these two numbers that are playing in the positive and negative direction away from the hard-coded script that's in the Python script. And because they're user objects, if you get those user objects, you can open up those scripts and see exactly how they're made and what's written. Then I'm going through a list item just to find out how to write some circles, and you can see that simple geometry that's out of here. So what I do after that is I go in and write a little more about linear regression, talk about the script and what's actually happening there. But before I go on to number 2, I'm going to be covering 10 machine learning scripts. They're in here. The next one's going to be logistic regression and the sigmoid function, which averages more between kind of limits as opposed to just going on infinitely. It's kind of categorizing things, yes, no, true, false, things like that. There'll be a lot of data there. But what I'm going to do before I jump into those sections is I'm actually going to make geometries. And I'm going to call these the linear regression Wickerson Studio geometries. And we'll cover this one in detail. So we don't need that first one. So I can leave that one. And what we have here is a little geometry that's in EnviroMap, which isn't very exciting to look at, but actually the whole script, just to see for a second, actually is pretty nice on turntable. It's a little shifted, but you can see it does some funkiness here, and it's playing with, it's kind of turning inside out, becoming a non-form. That's just the loft, but my main point is that the geometry is scripted by this. So if I take a look at that, and I decide, okay, what exactly is happening as I go through the script, and I build a simple geometry through the circles, and I generate this breadth, that breadth, if I start to play with the data that's coming into the function for the linear regression, like say this one, and just throw it through a little animate and go from -10 to 10, you can see that object itself kind of mirrors itself on both sides, and it's just changing the radii of those circles, but in the same effect, it's changing the angle of those circles in degrees. It's such a simple 101 Grasshopper script, but the key to it is I'm running scikit-learn. I'm using machine learning. I'm using linear regression to build geometries. Now, this is hitting a whole conceptual, abstract mode on a very basic level that I think anybody can follow. So let's take a look at what's happening here. Let's pull this one out, go to visibility, take that one off, and say, okay, here's the script. Let's balance it off in the center, basically around 0. Okay, there's nothing at 0 if it's not predicting. It doesn't need to predict 1, 2, 3, but let's go up and let's just predict this shape in a couple of directions. Let's predict it down here to Z. And so you get all these different forms, and you'll see how those are lofted differently. I wonder what number is actually best to look at. Probably 5. Let's zoom in here and see how that one is. And just let me send that back to standard, and zoom extends all, and we'll zoom in here and have a peek at it. So it's a nice little strange form that's been twisted, turned in on itself, overlapped. It's awkward if you want to take a look at it in different modes. Arctic, it's going to have a strange render. If we take it over to shaded, you can see that object. If we want to see how it's actually generated wireframe, that's kind of nice as well. But we'll have to bake it to see that, and I've got to bake on this. So what I did was I generated a series. You can see my series is 0 to 238, with the steps 2 starts at 0 and goes up to 120. But because there's step 2, it's going to jump in double, and that's just what's going to happen. So that series is generated. It comes into this script, and this script is running, as you can see, with all my other things up and running. And I did have a hard-coded Apple NumPy array in here, but I decided, well, why don't I just import it in as a list? as integers, and then apply to that the list length. And I've written in the model, because this is how I've actually made the short forms for the libraries that are brought in. I'm using fit, I'm using range, and I'm using reshape, and I'm actually parametrically controlling the x and the y to where I want to go, and I'm predicting the 1 and 2 that comes out of it, out of these lists, so I can actually use that data. And I'll get negative 10 and 50, and as I slide through x and y, so let's go to negative 10, we're going to get digits negative 20 to 200, so we're actually getting floats. And if we go all the way up to here, we'll probably get 20 and 200, and if we hover near the center, we'll probably won't get anything. But what it's doing is it's saying, if this is the rung of numbers, if this is actually, let me go in here, if this is actually the series of numbers that's coming out, and you're running through 0 all the way up to 238, it's counting those numbers, and then it's adding to those whatever digits I want. It's adding x to them. It's moving off in that direction. It's predicting what the number will be in that location. And because we have 120 numbers, we could technically take this slider up to 100. Let's take it up to 210. And let's do predictions on those numbers if we're actually stretch outside of that. So I've gone from negative, and actually it might be best if I go in here and do the same negative 210, click that over the negative, and bring this one back down to 210 just for fun. Actually, we'll just bring it to 200 and 200. There we go. Positive, negative direction. And now we'll see the numbers. Look at that. It's estimating 4,000, 8,000 in that direction, which is just huge. And then you can see the numbers are predicting so high in both directions as we go, as we step outside, because we've actually we've allowed for those numbers to predict so high away from where it was. So that's going to really fudge things up if I start bringing x in such a high count. And I think I don't need to do that, so I'm actually going to bring it back down to where it was, just a 10 and a 10. Let's bring this one down to, where is it, 10, and bring this one down to 10, and the minus, and this one will bring down to 10. I think we better just stick with what we had to start, because that's a nice predictable number, and the geometries aren't outrageous as we go into it. But as it makes those digits, and we go plus and minus in those directions, I'm taking them in as a list. I'm grabbing the list item 2 because there's a lot more data coming out of here, because I have to be very careful with what I'm exporting out of the out, that I don't get stuck with things that I can't use. And I can't use some of the arrays back into Grasshopper. I just don't know how to do it yet. I'm still struggling with that, but I can certainly deal with floats and integers and such. So we end up making these circles. I'm going to leave the script now. I was trying to figure some things out down here. I don't think it's necessary to keep them in this function, because they were all things that I was playing with. So just to simplify this, not to confuse people, this you don't have to get into. It was trying to get into some data tree types. I'm just going to save that one. And this will be a user object if you want to play around with it. I don't know if I really have to make my experiments user objects, like how many people really want to remake this geometry. And then I just do the old 101 Grasshopper, moving in the z direction, rotating, using the multiple angles as a list, 12 and 72 as degree shifts. I have flattened everything as it's come in as 2 separate lists, and I lofted those forms. And that's really what's happened here. You can see how this thing's turned around on itself, done some twisting. It's not making too much sense. And then I throw it into a grep, just cap the ends, and I've got this strange form that kind of floats in on itself. It's still going to have a little trouble. And then I throw it to a bake, and if I want to take it out as a bake, I don't know why I want that object, but there it is. You can see how the data or the geometries are actually driven. And then if I wanted to throw that into something like you can see that there's this kind of nipple tucking back into itself. So you get these pretty simple geometries. There's nothing too fancy about them. I do like artistic. Can't say I would generate this form, but what's happening is from the data that I've brought in, because of this series, and we can go back on here and say, okay, that was 1. What happens when we start playing with this series? What happens when I start bringing this down? Not so much, but this is going to have a major effect on it, because this has to divide through that series as it goes. And we're left with this as a count from 1 to whatever number I want, and then this one I can twist around and grab another geometry. So I just think it's pretty fun to be dealing with a series and a list, making these geometries. Grab this one, which is actually pretty nice, and if you like that one, then we can take a look at them both. Throw this one into a bake, throw this on layer 2, and there we go. And I think we can leave our form here. And there we go. You have 2 geometries over top of one another. Can't say I would ever build geometries like this. They're pretty beautiful and organic. There's 2 here if you want to move them. And I just think the power of NURBS curves associated with machine learning is where this is going to go. It's pretty 101 stuff to start, but it is not 101 when it comes to trying to get this up and running and getting psyched. library working, going through your, you're going to have to use your shell and import all these other libraries after it's open. Actually, you have to get into remote server. Where is it? I've loaded up all the other ones. You have to make sure that you're working within the remote. I can't remember what it's called, but if you don't have the Rhino ghPython remote on, or you're not going through Rhino remote here and found where it is in your location, you're gonna have trouble importing any of these, and then any of your scripts are not going to run when you start to bring off saying, okay, run these through those sticky script context sticky, and then the list with the string of what you're bringing it in as in your modules. So a lot of information here. I know it's kind of confusing, and I do talk awfully fast, but my concepts are not that complex. I'm getting them, and this is a nice little sample. I'm happy with it. I'm going to probably grab this one sample, tuck it all into this one, add to group. And there's a nice little exercise with 2 parts showing you the Grasshopper use of data, which is how you kind of start learning Grasshopper, and then how you can start really going to the ends where you know data science and machine learning. So I hope everybody finds that helpful. I hope you find it useful. I hope you keep watching and having a lot of fun at Wickerson Studios. And thanks to my Patreons, and thanks for the $25 members. And I look forward to talking to you whenever you want to make contact to me. So thanks, everybody.